Thank you very much. I hope you can hear me. Thank you very much for having me. It's a privilege to be among you. I didn't expect to learn so many things during these days, but this event was great, and kudos again to the organizers. My name is Madalin Neag. I am EU Policy Advisor at OpenSSF. I am one of the Linux Foundation staff. I have the privilege to represent OpenSSF, Linux Foundation Europe, and the Linux Foundation in the interactions with European Commission, EU regulators, standards development organizations, and most importantly with our community and other open source foundations in Europe, but not only. Today, as Andy said, I'll try to explain how to connect upstream to global regulations. And for that, we can use OpenSSF projects. We know how fragmented the regulatory landscape is, but not everything is applicable, or I would say that nothing is applicable to upstream from this regulatory landscape. Everything is applicable to downstream. But nevertheless, upstream can do voluntary job in order to enhance the supply chain security. And for that, we have some tools. And this is what I will try in the last part of my presentation to show how to bridge open source security practices with global regulations. But let me start with a brief introduction about the Linux Foundation. I hope you all know what the Linux Foundation is. Few numbers in order to clarify those things. We are talking about more than 1,500 projects under the Linux Foundations. We have more than 89 million lines of code added weekly, and more than 21,000 contributing organizations. Take into account that we have only 2,000 members. So we are so open that we care a lot about our members, but we open the floor for contributions to everyone that wants to come and help us with what we do there. We fully understand open source value because thanks to you, to the community, we have managed to put open source components across all layers, from open hardware to open source applications. And this year, Black Duck has published a study called OSSRA report, and they have discovered by scanning almost 1,000 code bases that 98% of them are containing open source. Yes, I know it's very complicated to quantify the value of the open source in this world, but Harvard has done a study, and back in 2024, they arrived at some numbers, and you'll understand the value of your contributions. So practically, we are talking about the cost of creating the code being $4.15 billion versus the value of the code generated in the market from goods and services built with it, which is $8.8 trillion. That's the value of open source. And that spans beyond. We saw that reported benefit to cost ratios from open source software contributions are somewhere between 2 and 5 times on average across engagement types. Open source software contributions increases product development speeds by 10% on average. Contributors benefit from at least 2 months advance notice for important changes. And an economic model reveals that $3.9 billion in investment from top 100 contributors between 2018 and 2025 yields $23.2 billion in benefits, so 6 times higher return of investment. Also, getting involved in open source is linked to stronger talent attraction and also can be used as a lever for quality and competitiveness. But also that creates dependency. As I mentioned before, 98% of the code bases scanned by Black Duck have reflected that they contain open source. Mean open source software components per applications was reflected as 1,180. So So we have 1,180 components in average per application. And we can have up to 50 projects per code base. Every organization is dependent on the security practices of open source maintainers, the licensing decisions made for open source projects, and the continued viability of those projects' components. And this is where OpenSSF appears in landscape. We are a diverse global community trying to make the world a better place through open source software. We have a simple mission, making it easier to sustainably secure the development, maintenance, release, and consumption of the open source software we all depend on by creating tools, education resources, and clear and actionable guidance. We want to enhance the security of open source software through the development of the tools, but also through different processes and guidances. And yes, we want to be the catalyst for change. We drive the collaboration with open source software producers to promote secure by design and secure by default. We try to educate and empower the modern developers. And also we are an ecosystem leader, leading collaboration and advocacy on open source software and supply chain security, being involved in standards, policies, and technical discussions with governments and industry. And we are doing all of those through 8 working groups. We have best practices for open source developers, AML security, open resources for baseline interoperability and tooling, securing software repositories, global cyber policy, and so on. Arriving at our subject, I mentioned that we have a very fragmented regulatory landscape, but that is caused by the fact that we have a very wide cyber threat landscape. IBM in one of its studies has reflected that 44% year-over-year increase in exploitations of public-facing software or system applications. The cost of cybercrime in 2025 was $10.5 trillion. And 65% of the organizations reported experienced a software supply chain attack in the past year. So supply chain hacks and zero-day exploits can hit everything. And if we are going into the cloud-native environment, we see that the numbers are even higher. 97% of organizations experienced at least one cloud-native security incident in the past year. And 75% of organizations have slowed or delayed applications deployment in the last 12 months due to the security concerns. Those incidents were significant for 92% of the organizations. And if we are looking at the landscape of tools, that's extremely worrying. Because one of our studies, yes, we have Linux Foundation Research, which has developed this amazing habit to develop great studies, and one of those is CNCF Annual Cloud Native Survey, the infrastructure of AS future. In that one, cloud native adoptions reaching 98% was shown. And maybe the highest praise that Kubernetes can get was that Kubernetes was named or was mentioned as boring. Everyone is using Kubernetes nowadays. And these CNCF projects are powering the critical infrastructure. We can see those deployed in finance, healthcare, automotive, governments, education, energy, transport, aeronautics. So it's normal that these kind of regulations are applying to CNCF projects in multiple ways. We're talking also about hyper-connected complexity. Nowadays, cloud-native applications rely on hundreds of transient open-source dependencies across multiple registries. Manual compliance is impossible at this scale. And yes, there is also the 90% problem. We have code bases with components that are older than 4 years at 92%. We have code bases with components showing no development in 2% at 93%. Code bases with components not using the latest version, 93% again. So it's somehow normal that different countries or European Union are trying to strengthen their resilience against cyber threats and to secure the supply chain. They are aware that this modern software is powered by open source. And therefore, all these kind of regulations, laws, are made for this purpose. Looking only at the 2020 EU cybersecurity strategy, we see two types of laws. Cybersecurity focused, like Cybersecurity Act, NIS2, Cyber Resilience Act, DORA, or EDA, which is still in place, and pieces of legislation that include cybersecurity provisions, like AI Act, Machine Regulation, or Data Act. Nevertheless, for downstream, but also for upstream, there is a need for comprehensive harmonized rules on how to address all of those. And stopping only at NIS2 directive, DORA and Cyber Resilience Act, maybe those are the most known for everyone in this room. NIS2 directive focuses on 18 critical sectors like energy, health, digital. Coming back to previous slide where I mentioned that CNCF projects are deployed across these important areas. Yes, NIS2 is trying to regulate that thing. In terms of supply chain, there is a direct requirement to secure open source components or to be mindful on how you ingest, as manufacturer, how you ingest the third-party components coming from open source. DORA is a NIS2 specialized, if I can say that. Is a lex specialist for banks, insurance, and investment firms. It has a strict control over ICT service providers like cloud, open source software, and so on and so forth. And yes, it's very similar with NIS2. It tries to secure the supply chain. It has this third-party oversight when it comes to the products that the financial sector is using. And maybe the most famous one is Cyber Resilience Act, where we see principles like security by design, security by default, applying to all PDs in the European Union, and the liability for manufacturers when it comes to entire product, including third-party components coming from open source world. And yes, if you're a manufacturer and you don't have enough resources to deal with security, show to your higher management the penalties for this. Additionally, looking broader, we see that global cyber policies are expanding even further this landscape. In US, we have NIST, we have CISA, we have also national pieces of legislations or national guidelines coming from organizations like BSI in Germany or NCNC in UK. We have legislation in Korea, in Japan, in China. And also we have standards. Maybe you're familiar with ISO, you're familiar with OpenChain. Global cybersecurity legislation is continuing to grow. And that expands the compliance obligations for enterprises, but also for manufacturers, impacting, of course, upstream open source developers and projects. And that comes in the context of continued lack of trust in open source, despite it being transparent. And therefore, we want to bring downstream to upstream, because security is most successful when it meets developers where they are. Downstream shall not consume passively upstream components, but they should, or they shall, get involved into upstream and contributing actively to those projects. Yes, we have 74% of organizations perceiving the effectiveness of cyber-related regulations as positive, and only 26% as negative. But besides that, we see regulatory pressure. I mentioned EU's Cyber Resilience Act. We have NIST-SSDF in US. That's a lot to handle, only mentioning 2 of them. Security teams are overwhelmed by static analysis noise and manual evidence collection. That shall not exist. We need to talk about machine-readable signals that could be automated, that could be used for speeding up this compliance process. And yes, organizations are lacking automated ways to prove the integrity of third-party artifacts. That's a pity. Take into account how many open source software components downstreams are using. Manufacturers have tried to do this shift left compliance, forcing compliance onto developers. That's a very bad thing to do. And we just hope that this will not be propagated. No matter how wide this regulatory landscape is, we still have some synergies. We see the review third-party relationships, risk assessment, technical documentation, reporting procedures, documenting compliance efforts, among all those pieces of legislation or among all those standards. And this is where I have tried to create this kind of approach on how upstream can help downstream to be compliant and what upstream can do. Let's start with the most important thing. FOSS projects are not suppliers, no matter what maintainers or other legislations are trying to say or trying to induce. Last week, there was concluded a NIS2 public consultation, and after many years being active, they have noticed that the obligation to ensure appropriate level of security in their supply chain has led many entities to request extensive information from their suppliers through heterogeneous questionnaires, formats, and processes. Additionally, we have NIST-SSDF. Those are paper-based attestations signed by upstream. And at the level of SAN, in their works related to CRA standards, there was also an idea to introduce this kind of supplier contracts into the standards. We shall not get there. Indeed, we have Article 25 from Cyber Resilience Act that deals with security attestations of free and open source software. That's very risky if done wrongly. Let's try to do that in the good way or in the best way, which is using machine-readable signals. You, as maintainers, you don't have any legal obligation. Everything that you do for this is a voluntary work. And continue to do what you have done until now. Prioritize innovation instead of compliance. You can do, still, you can go in your repo and add some machine-readable signals proving security by design, security by default, or best practices that could help downstream. And that will lead to easier adoption by enterprises, by the downstream, increased trust and credibility, reduced compliance friction, and also you can show a clear roadmap for security maturity. But make the difference between transparency and assurance. Do not sign papers for that. And yes, projects like K3S, for example, and Argo, Privateer, and many others have already included so many good things in their repos. You have the so-called self-assessment MD at the level of CMCF. Use that. Document your security best practices there. I will never cease to present K3S as a very good example. And yeah, that's a voluntary work. The people involved in that project have done a tremendous job. If you want to go a little bit further, you have 22 projects coming from OpenSSF. Maybe you have heard about some of them, like Salsa, Scorecard, Guac. I don't know. I hope you have heard about those. Salsa, one of our projects, have done a very nice exercise to put all those projects that we have in our portfolio on the various development phases, going from developer to consumer, passing through source code, build package, and how those can be used. You have here the map, the cartography of those projects and how those can be referenced or can be integrated in your flows. As you may see, as you may notice, most of the projects can be mapped on package selection information. And of course, these projects are free. You can use them, you can adapt them, you can create your business on top of those. We have already so many companies relying on our projects, and not only for proving or for checking the supply chain security, but also, as I said, for creating some kind of business model. Baseline is maybe the first tool that appears in everyone's mind from OpenSSF portfolio when we are talking about regulation and upstream. It helps navigate this diverse policy landscape. It contains different types of standards, different types of regulations on which you can put or you can map different set of controls. And yeah, it's evolving, it's continuously evolving. Connecting developer security practices with international regulations, helping in due diligence processes, supporting compliance across multiple frameworks, and offering a reliable evidence-based foundation to build trust across the global open source ecosystem. Besides Baseline, we have plenty of other projects that can be used in this process. First of them, Salsa, which is practically an artifact integrity framework, a checklist of controls to prevent tampering across the chain. You can think of it as food safety handling guidelines that make ingredient list, the SBOMs, credible. We have 4 assurance levels from L1 to L4. It has a common security vocabulary, and yes, it's a very verifiable build provenance. Additionally, we have Scorecard, automated risk assessment that evaluates the security postures of more than 1 million open source software projects. And we have also best practices badge in this category, which is project self-certification, allowing open source software projects to demonstrate adherence to industry standard best practices through voluntary self-certification. Additionally, we have security insights. That connects the simplicity of security md.file to an SBOM, filling vital reporting gaps, automating ingestion ready, and using a standardized metadata schema. We have Guac, which practically can take the SBOM, security MD files, VEX data, Salsa attestations, scorecards, to reveal hidden dependencies, risks, and organizational version sprawl. And that also can be used to generate machine-readable attestation for compliance with regulations. We have also Sigstore, which practically is a VEX seal of security. There have been so many ways to sign a code or a repository, but yeah, who can certify the keys that have been used? We are coming in this landscape, and we have developed Sigstore. Talking about SBOM and reflecting practically the components that a downstream manufacturer can have. Of course, we have 2 standards, and I'm using standards per se. SPDX and CycloneDX are standards. SPDX is at the level of ISO. CycloneDX has been transformed into an ECMA standard. But at the level of OpenSSF, we have come with some tools in order to complement the usage of those SBOM tools. So we have Protobomb, which practically can help transforming SBOMs from SPDX format to CycloneDX format. We have BOMCTL, which practically can help connecting SBOM generation to SBOM analysis and can help integrating the SBOMs in your CI/CD pipelines. And also we have SBOM IT, which enhances the information that you can receive through an SBOM. And yes, we can map all those tools and others, because I do not have time to go through or to present all of our tools from our portfolio on 4 categories: assess, sign, automate, verify. Trying to operationalize the trust through continuous verification and machine-readable signals can help in your intention to automate the traceability, checking the build integrity, showing structured transparency, and also fighting for a sustainable ecosystem, avoiding misallocated responsibility, and facilitating due diligence processes. Yes, in order to conclude, I would like to start with this phrase that compliance is becoming unavoidable, but keep in mind that manufacturers remain responsible for risk-based decisions. Upstream signals are mere inputs. Passive consumption is obsolete, and I hope that all the downstream actors are understanding this thing. Security gaps must be addressed through active tooling, funding, and engineering contributions to the ecosystem. Pieces of legislations like CRA will increase the cost for security things in your companies or in audit processes. In terms of, or touching only CRA, Red Hat study from this year has reflected that 64% of those companies expect that their cloud-native security investment to be increased. And I mentioned the tools that we have at the level of OpenSSF, but also I would like to mention other 2 working groups, or in fact, 1 working group and 1 special interest group. Working Group Global Cyber Policy, where we discuss all the complexities of the regulations, and Launchpad SIG, which was created practically to bridge between the regulations and the tools that we have in our portfolio, and not only, mapping them on the regulations demands. Cloud-native projects are powering critical infrastructure, and therefore you have to deal with complex regulatory landscape. The tools that you develop, or better said, the CNCF tools landscape, can be found everywhere, from communications to government, from transport to chemical industry, from financial to commercial facilities, and so on and so forth. You're not liable for any regulations demands, but you can contribute to the downstream compliance. Improving confidence in upstream dependencies, simplifying vendor risk assessment, showing evidence-based security posture, and of course, removing the ambiguity and fear for open source software. But keep in mind, do not assume financial, contractual, or legal liability. Do not sign papers that could bring you in this posture. And it's up to you to choose. World Economic Forum Global Cybersecurity Outlook in 2025 presented 2 perspectives. 69% of the survey respondents found regulations too complex or too numerous, or having difficulty verifying whether third-party suppliers are compliant, while 78%, so practically in the same time, has or have answered that cyber and privacy regulations are effective in reducing their organization's cyber risks. While it's difficult, they can reduce their organization's cyber risk. Up to you to choose which path you have to follow. But remember, all these activities are engineering improvements, not regulation requirements. Open source maintainers already contribute critical infrastructure, donate time and expertise, and enable innovation across the digital economy. The intent of adopting regulatory efforts across open source ecosystem is to support and not burden maintainers. And with that, I will close. Thank you very much for your attention.